Aloha and welcome to what I hope will be a relatively brief screencast about the data model in Bowfolios. But I am going to cover a few different things here, so it might take a little more time. But it's critical because this is one of the main features of this application is to get away from the kind of trivial case where you have these collections, they're not really related to each other, and you have a form, but the form just updates one collection at a time, and that's not realistic. And when you try to build a prototype for an application that has kind of a non-trivial data model, which will hopefully be the case for everybody in this class. So let's review this application. We've got this idea of profiles, projects, and interests, and you can see they're all tied together. So for profiles, for a person's profile, we want to know their interests in the projects they're associated with. For projects, we want to know what are the interests associated with them and who is working on them, what are the profiles associated with it. Similarly, for interests, we'd like to be able to know who are the people that have specified this interest, the profiles that specify this interest, and the projects that have specified this interest. So because everything is all interrelated together, the thing you might think, which is to, well, I'll just have some kind of field in the profile collection with an array of projects. That's not going to work very well when, now you're trying to look at the data from the perspective of projects and find all the interests and users and so forth. And so I kind of deliberately created these three things to make it clear that the standard way where you just start, you have a profile-centric data model isn't going to work. And the solution to this is to essentially extract out the relationships between various collections into these kind of helper collections that I call join collections, because what they're going to do is they're going to enable you to have many-to-many relations from talking in database terms of between collections. And so we have a profile. We have profiles, we have projects, and we have interests, and those are our three primary collections that have data. And then we have three other collections: profiles, projects, profiles, interests, projects, interests, that just store relationships. So when there's a relationship, when we want to connect a profile to a project, we add an entry to this collection saying for this specific profile, it's related to this specific project, and then we can query this table either for all of the profiles associated with a project or all of the projects associated with a profile, and all of a sudden generating any of these views on the data becomes extremely simple because we're just accessing these tables. When we do updates, then we have to we not only have to update the profile class, we also have to update these secondary helper collections as well. I didn't mean class, or I meant collection. The other thing I want to note about the data model right away is that we have this notion of a primary key or a unique field associated with the three primary collections: the profiles, interests, and projects. And as you're going to see in a second, that's really important when we're trying to initialize the database on startup with some sample data. We need a way to be able to have a string. We can't use the doc ID because the doc ID doesn't exist, and we want to allow the system to just automatically specify it. So instead, what we're going to do is we're going to declare a unique, a primary key, or a field with only unique values in each of these three collections, and that makes it really easy to build up our sample data set and load it in. Okay, so that's the idea of the data model at the high level. Let's now look at the code and see how that's implemented. As I talked about last time, when we start up the server, okay, in main.js, we're going to load this file called startup server Mongo, which is right here. And the idea here is, if you look at the bottom, we have this if statement that says, if the database appears to be empty. So I'm assuming that if there's no users in the database, there's nothing else in the database, and we want to load some code. We want to load some default definitions for profiles, interests, and users. So what I then kind of check to make sure via this conditional, just to see that the user has specified a settings file on the command line. So you realize that when we, or you might have seen that every time we run the system, we always say meteor npm run start. And the reason why we use that is so that we run the script in package.json called start, and that script says meteor with a -- settings flag load in .. /config settings.development.json, so that this file gets loaded as the settings file on startup. And what that means by being the settings file is that we can now refer to the contents of that file, which should be in JSON format, via this top-level global meteor.settings. So this conditional just says, does the default projects field and the default profiles field exist in settings.development.json? There's the default profiles. There's the default projects. So yes, indeed, they do exist, and so therefore we're going to go ahead and actually try to initialize the database with the contents of the settings file. Otherwise, we're going to say, hey, it looks like you probably ran Meteor without specifying the settings file. So, you know, boo on you. I mean, the system will still come up, but you know, you're not going to have any data in it, which is probably not what you wanted. So, so we'll say, okay, we're about to create the default profiles. That's what. Where's that line? Here it is, creating the default profiles. And then what we're going to do is we're going to go through each of these default profiles, extract one, and call the add profile method. So if we look at a default profile, what you can see is a default profile consists of an object. It's got a bunch of fields, and also, interestingly, it has an internal field called interest and an internal field called projects, which is like the structure that I was just saying a minute ago was not the good structure for our collections to have. And indeed, our collections don't have that structure. But when you're defining, you know, your initial data, why not go ahead and do it? Okay, and what we're going to end up doing is we're going to end up hoping or requiring through, you know, hand checking in the settings file that if I specify a string as a project in this default profile, then later on in my default projects, I better have a project defined with that same string. Otherwise, things aren't going to work very well. So you've just, you know, when you're loading your default data according to this data model, but I could automatically check for this kind of integrity in these different definitions. That's, you know, not hard to do. I just don't do it. Just by hand, by hand inspection, you have to make sure that you maintain integrity. If you refer to a project in this default profile field, you better define it as a project later on. Interests are a little different. There is no default interests field in this settings.development.json. What I do in the system is to say, well, heck, if you have a string here, we're just going to define that as an interest, or ensure that it's defined as an interest, because you can, you know, refer to these same strings in multiple places, obviously, and so part of the loading process is to just implicitly define interests whenever it runs across one in any of these definitions. So otherwise, you know, this looks like a pretty standard. You know, we got some fields that, you know, actually exist in the profile collection, and other fields which are going to end up being put into these helper join collections to indicate the relationships. Default projects looks the same thing. You know, name, home page description, those are fields in the actual project collection. Plus, we're going to have some interests associated with the project, and we don't have to say users or participants because we already did that up here, right? So we don't, you know, that indicates a bidirectional relationship between profiles and projects. We don't have to redundantly specify it in this other section. So that's what settings.development.json looks like. And so if you read the code, it should seem pretty straightforward at this point. We're going to get all of these fields out of the object each object associated with a profile. We'll call create user, and that's just going to use the accounts create user package to define the user for authentication purposes. And then we're going to go ahead and call profiles.insert because the insecure pack. I'm sorry, this runs on the server side, so this is totally fine. So we're going to insert this this document into the profiles collection, and then we're going to add a document to our join collection, profiles interests, where the profile is the unique ID associated with the profile, which is the email, and there'll be an interest field, which is the unique ID associated with the interest, which is its name field, which is just the interest string. Similarly, we want to set up relationships between the profile and each of the projects that it was associated with. And so to do that, we'll call insert into this array with the profile being the unique ID of the profile and the project being the project string. And then finally, we're going to make sure that any interests that we refer to here are in the interest collection. So we call this add interest.update, and we use this upsert keyword that says, okay, well, if you see an insert, if you see an interest in there with the name, we're just going to set it. Actually, we could just do nothing in that case. But the nice thing about doing it this way is if it doesn't find it, it's going to actually add it. So we get the interest being defined without putting a conditional in there. Okay, so this may, just to kind of help you visualize what this looks like, let's bring up Robo3T, which is a nice way to inspect the contents of a Mongo database, and it's very easy to configure to look at this localhost file. And so let's just kind of cruise through these collections so you can see. So if we look at interests, well, you can see there's a doc ID, and then there's just the name of all the interests. So that's a very simple collection. Profiles has the first name, last name, bio, title, picture, and then the unique ID, which is the email associated with the user. And we can also use this as a way if we need to figure out, this kind of connects the document in the profile collection with the Meteor account's username, which is also the email of the logged in user. Okay, so let's look at profiles interest, because that's the class that establishes the relationship between profiles and interests. Okay, so let's expand this. And just to make it clear, it's probably good to let's go ahead and go back to our system here, and let's look at me. Okay, so here I am. My profile is here, and I'm saying I'm related to these two interests, software engineering and climate change. So let's go back to Robo3T, and what we can see is that there are exactly two documents in this collection associated with me. Okay, and it says, and those two documents have interest field software engineering climate change. Okay, so that's how I can use this collection when I'm creating this tile to figure out what are the projects associated with me. Let's go the other way, and let's say we have the software engineering interest, and we want to know who are all the users associated with that. Well, in that case, we can go back and go software engineering. We can kind of use the search on this second field, and you can see that software engineering appears in these two documents, and the two profiles associated with that are Johnson and Seymour. And that's how we get these two little photos in this area. Okay, so that hopefully gives you a concrete sense for how we, what the data model looks like, why we want to have these join collections, because we want to be able to, kind of portray the data, represent the data in different ways, and understand the relationships in different directions. We've also seen the database initialization process, and so the final thing with respect to the data model are publications and subscriptions. Okay, so remember that when we loaded the system, we defined these publications, which specify on the server side, hey, if you want to subscribe to this string interests, I'm going to populate mini Mongo on the client side with all of the data in that particular collection. Okay, and let's see how this works in practice with a couple of pages. Let's start off by looking at the landing page. Okay, and remember the landing page is this one right here. Okay, and if you look at this, you say, well, I don't actually see any data here. Okay, these are just static screenshots, and if we look at the code, you can say, hey, yeah, there's no subscriptions going on here at all. Okay, so what that means, and this is a really useful thing to do, you can bring up the Chrome Developer Tools and install the Meteor Chrome Developer Tools package, which then enables you to see the contents of the mini Mongo database that's running inside your browser and is set, depending upon the page. Okay, so what we can see here is when we're at the landing page, there's nothing. We got nothing, right? Because there's no subscriptions. On the other hand, let's click and go to profiles. And what you can see if you look down here is all of a sudden we have 6 profiles, we have profiles interests, profiles projects, 4 projects. Basically, we don't have projects interests, interestingly, but we have all these other ones, okay? And that's because if we go to the actual code associated with the profiles page, what you can see is we've subscribed when we run this page, when we render this page, we use the with tracker option when this is just kind of standard Meteor practice to wrap the React component profiles page in this with tracker higher order component, which enables you to subscribe to various collections and then set a property, typically called ready, when all of these subscriptions have been satisfied, which means all the data has been transferred from server to the client. And what we do to make that work correctly is we define our render method, which is the one that gets called by React, to say, hey, either render the actual page, the contents that we want, in the case that this ready is true, while it's false, because not all the subscriptions have been completed, we're going to render this loading icon, which is a little spinny thing. And these things, they load pretty fast. So oftentimes you won't even see this loader appear at all. You're just going to see the page, and it's just because things go fast. Okay. So you notice that the profile, the projects interest collection. If we go back here, projects interest has nothing in it, and that's because we didn't subscribe to it. Okay. So on this particular page, nothing is that collection won't have anything in it. Let's go to this page, the projects page, and all of a sudden now you can see in mini Mongo, projects interests does have values because we need that subscription in order to fill out the interest associated with each project. And so if we go to the projects React component, you can see, yeah, we subscribed right here to projects interests. Okay, and so the other thing to note, if we go back to Bowfolios page, all of these, these collections go back to 0. So by default in Meteor, each time you visit a page, it sees those subscriptions and it subscribes to whatever data is needed for that particular page. You navigate to another page, all that data goes away. This can get inefficient in cases where there's data that you want to be put into mini Mongo and then stored because it's required by multiple pages. And there is subscription caching available for Meteor to to deal with that. So you can take care of this thing in a prototyping situation, small amount of data. It's not worth worrying about optimization at this point in time. And so we just leave it this way. As you can see, you normally never see any kind of problem by going back and forth. So things work pretty fast. But if in the case as the system scales up and you start to see slowdowns, this is what we've done in our other projects, you wait until you start to see slowdowns and then you do whatever caching is required to provide adequate performance. If you prematurely optimize, there's an old saying, premature optimization is the root of all evil, because you know, the systems, it's very hard to predict how the system's actually going to work in practice. It's better, you're better off kind of seeing what happens and then reacting to that. Okay, so that's the data model. We've seen how to initialize it. We've looked at publications and subscriptions. The final thing, just to reemphasize, is this notion of primary keys. It's very important when you're defining your collections to have this primary key, because that enables you to, for example, when I'm defining a profile, I can say, I can refer to a project by its name. I know that's guaranteed to be a unique string, and so I can kind of use that to look up the project. Okay, so how do we actually enforce the requirement that the project name be unique? And Meteor has a nice, the simple schema package, I should say, has a nice way to do it, and that's by, when you define a schema, you can provide these optional properties, index true, unique true, to enforce the fact that, first of all, the name is required, that name will be used as an index, which improves the performance of lookup, but more importantly, for our case, for our purposes, we can enforce uniqueness on that key. So you can see every single one of our, well, every single one of our three primary collections is going to have a field where we've said it's an index and it's unique. So for profiles, it's the email, and then for projects, it's the name. Okay. The join collections, obviously, we're going to have multiple occurrences in each. We can't have a unique field because we're always going to have typically going to have multiple occurrences of the same string in each of the rows. So if I just go back, you can see if we go to profiles interests, right? There's going to be multiple occurrences of the string Johnson at Hawaii.edu in the profile field. In the interest field, there's going to be multiple occurrences of software engineering. So there's none of these things can be unique. Obviously, the ID field is unique, but our fields here won't be unique because we're going to have, you know, it's many-to-many relationship. Alrighty, that's the data model. Hope that clears up any confusion you might have.